Hello, Math 101, Hazleton, Justin Pashara here once again. Decided to do a short video for you to help you with your upcoming quiz that you'll see on Blackboard today, quiz number 7, which deals with primarily actually just section 6.1. Today, I'm just going to do an example. I'm going to give you a set of numbers and we're going to classify all the numbers in the set. This is something typical that you see in every textbook. I believe number 11 and 12 in your textbook were problems like you're going to see here. They weren't required to do for the homework. They should have been actually, really, believe it or not. But I didn't put them in there. But this will be a good help because you may see something like this very similar on your quiz. So we have all these sets of numbers that we have. We have the natural numbers. We have the whole numbers. We have the integers, the rational numbers, and the real numbers, and we also have the irrational numbers. And as you can see here, I wrote them all out as subset relations. So the natural numbers are contained inside the whole numbers, which are contained in the integers, which are contained in the rationals, which are contained in the real numbers. And the irrational numbers are also contained in the real numbers as well. Now remember, this relationship doesn't necessarily go backwards. For example, not all rational numbers can be found in the integers. For example, 1/2 or -1/2. Those things are rational, but clearly not integers. So if you remember this subset relation, this will help you. You'll never get any of these problems wrong on a test, ever. But let's make up a set of numbers here. We'll call it the set S. And let's put some elements in the set S. How about pi? The square root of 2, the square root of 4, -1/2, 0.56 with a repeating 6, -0.1, and -13. And let me add a couple more. How about 7 and 0? Okay, that's not too bad, right? So what we want to do is classify these numbers into the subset or subsets that they belong to. So let's start with the natural numbers, n. Which numbers here would be classified as natural numbers? So those are your counting numbers, right? Those are the first numbers we learn how to count with. And at first glance, it looks like none of these here maybe would be natural until we get to the end, right? Hopefully you would pick out the number 7 would be considered a natural number. So 7 would be a natural number. 0 is not, remember 0 is not natural, but there's one other number here that's kind of in disguise that actually is a natural number. Do you see what it would be? It would be the square root of 4. Now, oftentimes we see a root and we think, oh, it's automatically irrational, but not the case here. Because what is the square root of 4? It is the number 2. So 2 is clearly natural. So the natural numbers in this set contain 7 and the square root of 4. Let's talk about whole numbers. What numbers belong in that set here from S, right? So the whole numbers are everything the natural numbers are. So that means you automatically have 7 and the square root of 4. And we also have down here the number 0. 0 is where the whole numbers begin. So that is the set W. Okay, what things would be considered integers? Well, it has to be everything that's in W. So that'd be 7, the square root of 4, and 0. And anything else up here would be considered an integer. Integers are, remember, the positive and negative whole numbers plus 0. So we would have to include the number -13 this time. You may be tempted to include -0.1 and -1/2, but remember, just because it has a negative sign doesn't mean it's an integer, okay? And that was one of the things that always confused me, like when I was in 6th, 7th grade, was that the way that our teacher explained it maybe was not the best way. The teacher made a comment like, oh yeah, negative numbers are integers, but not all negative numbers are. And these two would be perfect examples. So the set Z would have 7, the square root of 4, 0, and -13. That brings us to a bigger set, which is the rationals. So the rationals, remember, are quotients of integers, and that's a new term you're going to see in your lecture notes and exercises for section 6.3, is quotient of integer. That's a fancy way of saying fractions. So the rational numbers have everything the integers do, so we automatically include 7, the square root of 4, 0, and negative 13. And now we look for quotients of integers. So negative 1/2 would satisfy that. Something like negative 0.1, because negative 0.1 would be negative 1/10, 1/10. And then this guy here, the 0.56 with the repeating 6, remember rational numbers are considered also to be terminating or repeating decimals. So we have to include 0.56 with the repeating 6. And all of these numbers would be considered rational. So the rational numbers are 7, square root of 4, 0, negative 13, negative 1/2, negative 0.1, and negative 0.56 with the repeating 6. That takes us to the irrational numbers. And remember, irrational numbers are all the numbers that cannot be rational. So if you see, when you see all these elements in Q, you better not write any of those down here because it's impossible. Irrational numbers are non-terminating and non-repeating decimals. The classic one would be pi. That has an approximation of 3.14, but it is not exactly 3.14. And the square root of 2 is also in that similar category. The fact that we can approximate it, but it's not exact. So those would be irrational, pi and root 2. And the last one is usually pretty easy for us, the real numbers. That would be everything that belongs to S. All these numbers that we have listed in S here, all these elements, would be considered real numbers, of course. So I hope this example helps you a little bit. You'll see a question like this in your textbook, perhaps. You'll see a question like this on your quiz. So until then, I hope everybody's doing well. Shortly, in the next day or so, I'll have another video for you all on material that's found in section 6.3. 6.3 contains only the rational numbers, so we'll be looking at exclusively this set. And the best part about that is this, for our spring semester, is our last topic. So you'll be happy to know that section 6.3 is the last of new material before we take our final exam. So I hope everybody is healthy and well. Hope you have an enjoyable day, and I'll see you next time.